The non-nail system was introduced onto the market by Dyno Nobel a little more than 25 years ago, and the system has revolutionized rock blasting to say the least. Thanks to the system being entirely insensitive to the effect of electric fields, it has been possible to electrify operations like drilling, dewatering and transport. This has contributed to the improvement of the working environment, both above and below ground. Non-nail Unidet was conceived for easy handling of surface blasting, where practically any size of round can be shot safely. It's only the working site that sets the limits. Most of the production is carried out automatically by means of robots developed by Dyno Nobel. Here, surface connectors are produced in a machine which is operated by one person only. The high degree of automation gives a high uniform quality. Checking is very rigorous. Each box is weighed as an extra precaution to ensure that the right amount has actually been packed. The level of automation is equally high in the production of in-hole detonators. The particular detonators that are being produced here are to be delivered by air to Japan, and therefore must be packed in a different way. So this procedure is carried out in a special packaging room. To Dyno Nobel, it's become routine to deliver non-nail detonators by air all over the world. Non-nail is a non-electric initiation system which is modelled on a conductor line of low energy type. The shockwave goes through the line at a speed of 2,100 meters per second. When the shockwave enters the delay element, it is slowed down for a preset time and then ignites a small base charge which transmits the shockwave to one or several tubes. The principle of bench blasting is to split the rock into slabs. The process allows for one slab to be moved slightly before the next starts moving forward. The rock swells on blasting and the first slab must move sufficiently to make room for the swelling. The thickness of the slab varies with the different types of working site, drill hole diameter and quality of rock. A thicker slab moves more slowly than a thinner one, and as a result it has to move for a longer time. To solve this, we've developed a system with surface connectors which delay the detonation by between 17 and 176 milliseconds. In this way, we cover all types of rock blasting requirements. On this working site, the Swedish National Road Administration is carrying out blasting work for the new section of the European highway, the E20. The blasting involves low bench levelling, and the position of the working site is such that ground vibrations have to be limited. In order to have full control of the amount of charge in each hole, cartridge explosives are used. The round consists of 594 holes. As it tends to get dark more quickly in late autumn, charging demands a large number of workers in order to finish the work in daylight. But the hooking up is performed fast and easily thanks to non-nail snapline. All in-hole detonators have the same delay time. The initiation sequence of the holes is determined on the surface with snapline. Here we have a delay of 17 milliseconds between the holes in the rows and 59 milliseconds between the rows, and the result of this is that each hole has a unique delay time. This is a different type of working site. It's a quarry operation where a pumpable explosive is being used. The holes are prepared with a primer, which secures the initiation of the explosive that has been pumped into the hole. In the primer there is a U500 in-hole detonator. All the holes have the same type of detonator and therefore do not need to be laid out in any particular order. Here a top primer is being used, and this is preferable when using bulk explosives, especially when there is a risk of separation in the string of explosives owing to fissured rock or water-filled drill holes, for example. The holes are stemmed before being connected. The initiation sequence is determined on the surface with snapline blocks. And the hooking up? Well, it's both quick and easy. The round is spliced to a shot firing line. It is then extended to the firing site. Safe and simplicity itself.